Are you guys wanting the laser pointer at all? Okay. Hello, everyone. So to my left, we have Hanzala Hussein, Hayden Murray, so myself. We have Connor Clapson to my right. Over there, we have Catherine Avery. And finally, we have Alex Mayhew. And so in terms of our agenda today, we're going to go through our problem statement and some of the market research we did. We're also going to go through our design process. We're going to talk in detail about our final design. And then finally, we'll get into some prototype testing, and then we'll do a formal product demo for you. And with that, I'm going to pass it off to Connor.
Thank you. So there exists a real problem within dentistry, and that's back pain. 70% of dentists experience back pain. Now, this number is extraordinarily high compared to 7.5% of the general population. Now, our team further investigated this problem, and we talked to dentists around Saskatchewan. And turns out this problem is still evident today. So that's why our team designed a device to help ensure that dentists can practice their profession safely and confidently without injuring their backs. So our design process began with client interaction. We found it very important that talking with dentists and understanding the problem fully is very important to creating a great design. We iterated through many solutions, and we did this using a continuous feedback loop with our clients. And this is very important, like I said, to make a good design that can meet the needs and requirements of the dentists. Once we got our final design, we modeled it using AutoCAD, and we analyzed it to ensure the safety of dentists and the clients that would use it. After that, we ordered our parts, we assembled it, and we tested it. And I'll pass it to Hansla, who will talk about the final design.
Well, so now you know our product is aimed at dentists. The intended purpose of our design is to take the strain off of their lower backs when they're doing their procedures and leaning forward. This is done by a mechanism that pulls on to the harness that is wrapped around their torso. So the L frame is composed of aluminum extrudes for ease of manufacturing and adjustability for different individual heights and different chair sizes. And this L frame consists of a pipe clamp that can attach to stools with diameters ranging from 1 inch to 3 inches. And now I'll pass off to Alex.
Right, so one of the central components of the design is the spring box, which you can see as a render here. So it is what generates the force that supports the dentist as they're leaning forward. So it contains a wire rope with a set of 7 pulleys and 2 spring columns on each side. And that provides the restoring force. It also has an adjustable spool, which allows the user to set what they want the force to be, as it'll vary from user to user because of individual sizes. And then we also have a harness, of course, to attach directly to the dentist, and a self-aligning magnetic latch to connect the harness to the wire rope. With that, I'll pass it off to Catherine for prototype testing.
So for testing, we used an EMG machine with 2 sensors attached to the lower back to measure muscle activation. We took measurements at 70, 80, and 95 degrees of hip flexion to mimic what a dentist would be doing in a procedure. And we held each of these positions for 20 seconds, both with and without the device, to get a comparison of the muscle tension. So for our results, it was a relatively small sample size, so it's difficult to obtain sound conclusions. However, we did see some positive results. So the graph on the left shows when you're sitting upright at a 95-degree angle. And so the bottom 2 lines would be your muscle activation with and without the device for one sensor, and the top 2 would be the same thing for the other sensor. And so at 95 degrees, you can see the muscle activation is about the same, which makes sense because you're not engaging your muscles too much when you're just sitting upright. But at 70 degrees, you can see that with the device, which is the red and the dark blue line, the muscle activation is quite a bit lower than without the device. So this would suggest that the device is effective in removing the load from the lower back and removing your muscle tension. So now we'll go on to next steps.
Okay, so moving forwards, we intend to do some intensive prototype testing. We intend to do some further testing with a larger sample group. We intend to optimize the design to minimize the mass and to optimize it for mass production and stuff. And lastly, we want to do some further research into harness design and suit it to our intended use. Okay. And without further ado, I'll pass it on to Hayden to do the product demo.
Thank you, Hanzala.
So here's the big reveal. So as you can see, it's attached to the chair. As Hayden puts this on, I'll just show you guys some of the features here. Hopefully this is visible on the camera. Just slide it over a little bit this way because I think it was pointed in this direction. So as you can see, this piece is free to move up and down here with the pulley attached to it. All you'd have to do is loosen these guys off with the screws inside, and you could lower it down as well for any individual height. Down at the bottom, you'll see the little pipe clamp that we have. So it's essentially two 120-degree angled pieces of sheet metal. And that allows you to clamp onto any size of pipe for that center rod of the chair. As Hayden gets set up here, should be able to see. So here's the latch that Connor just installed there with the magnet inside of it. So as he leans forward, you can see that there's a little bit of deflection here. That's just something with the clamp that we will be looking at redesigning in the future potentially. But you can see that this provides a good range of motion. That's an effect of the pulleys on the inside. If you are on this side of the room, at least, you'll be able to see the plate inside that is connected to the pulleys rising and lowering as it compresses and decompresses the springs. And in terms of adjustability for different chairs as well, you'll note that these two pieces here that connect to the main extrude on the bottom can be loosened to allow this to slide back and forth. So that gives you, and
there's you can adjust this for different sizes, different people of different heights. So you can change the angle, and anyone can sit and use it.
Lean back just a little bit. Yeah.
so everybody else can see it. Yep, absolutely. Just spin the base of the chair as well. Yep.
Very good.
Which way? Oh, wait. Okay.
Good.
Yeah, you're
Yep,
good.
you're good to go.
Oh, man. Just for studying, you know? Oh. It's how far?
You can go a little bit further than that. Yep. So I should note one thing, with manufacturing timelines, we had to go with 3D printed parts in some places where these would ideally still be made out of aluminum sheet metal. And additionally, the bottom plate is currently made from acrylic and just laser cut from acrylic. Ideally, that would also be aluminum. So that's taking some of the load right now, which is concerning us a little bit, but.
I mean, I'll just.
Yeah, students as well.
All right.
Good. Thank you very much for the presentation. You've come a long way since November, so good work. So I did note that you've attracted the interest of an angel investor. What do you